So today mainly we'll be talking a little bit about some of the basic constructs that we saw yesterday, but we didn't cover these into detail because yesterday our focus was mainly covering input outputs and how to even read something. What does standard out and standard in mean, right? Things like that. So today we'll be delving into more of these constructs, which again are very fundamental to any kind of programming language, right? And these are not specifically just C++. These are things that you'll do probably in every programming language, irrespective of what you do where, right? So the first thing that we want to cover is some conditional statements. So most of you would already be familiar with, but the most fundamental sort of conditional statement is the if statement, right? So if some condition, uh, then do something, right? Um, else, you know, do something else, right? This is the most fundamental building block, uh, not just in programming, right? And don't worry about the syntax. I'm just trying to here explain some logical concepts here, right? So this is the most fundamental concept when it comes to logical thinking. So whenever you think about something, if um, uh, in the real world as well, right? Like, let's say, imagine if you're playing cricket, right? If you hit the ball in a gap, you run and score points. Else, if it goes straight to a player, you don't run, right? You wait for the next turn. So something like that, right? So essentially, this is the most fundamental building block of any kind of decision making. So whenever there is a decision to be made, right? So any kind of decision making needs to happen. This is where you will use that if else kind of a condition, right? Now, some of you are already familiar with other things like loops, functions, right? But from what I've seen when we did the round of interviews, right, a lot of students were getting confused as to, oh, am I going to use an if condition or am I going to use a for loop instead, right? These are two very different things. We'll come to what for loops are once we start talking about loops. But the point is that when you're logically thinking about something, you're making basic assumptions on certain conditions. Whenever you have a condition and a following thing that you want to do, that's where you want to use an if. All right. Of course you can do sort of fancier things where if you have multiple if conditions, right? So you can do if then another condition, right? And then based on that you can do something else, right? And then you can have the final else condition where you're doing something else, right? So if you hit the ball in a gap, then run and get score. Else if you hit a ball in a gap and it hits the boundary, you don't need to run, right? You scored 4 points, so increase the score by 4, right? Else means you didn't hit the ball at all, right? Or maybe you hit it straight to the player. Then you don't run, right? So you can see how you can build up more complex hierarchies using this. This is typically what we call chaining. So what you're doing is you are putting like, how you have a train, right? You have one block, one bogie of a train, then the next, right? These are tied together in a chain, right? So this is typically, the concept is basically called chaining. So you're connecting basic buildings. So if I just had this if condition, the first one, right? Then also the condition works, right? But now I need to explain, or right now I need something much more bigger than that, right? So I chain two conditions parallelly, right? So writing, I could have written the same thing, but in a slightly different manner here, where I don't have the else condition, right? So in this case, the first this if block will get executed, right? And then this if block will get executed, irrespective of whether the first if block was true or not, right? So in this case, both of them can get executed. But in this case, it's important to understand that this second else if condition will only get executed provided my first one was false, right? So that's a very important sort of a distinction, and you can have them in different scenarios. So we'll quickly take a look at um, some of the examples there. Anybody has a good example for demonstrating? I usually like to keep the classes interactive. So if you have any good example, like real world example that we can implement here, please just let me know in the comments, and we'll try to implement that as well, instead of going with some kind of a boring example from a book or something. So anyone in the chat? Let me see if there's anybody in the chat. Okay, nothing so far. Any kind of real world, I mean, we're going to take the cricket example, but it's hard to kind of implement it inside of conditions. But all right, so let's do something. So we'll use this kind of a condition. So most of you might have seen me ask you this question in the interview process regarding red blocks and blue blocks, right? So imagine if you're building a game, and this game consists of two colored boxes. Either a box is a red box or it's a blue box, right? Now, whenever you pick up a red box, you basically will get a score of 10 points, right? But whenever you pick up a blue box, you get a score of 20 points, right? So what we can do is that we need to calculate players' total score, okay, based on how many red boxes that the player has picked up and how many blue boxes that the player has picked up. So now the most fundamental decision that I need to do here is, when I take one box, I need to figure out whether it is red or whether it is blue, right? Now, if it is red, I need to give it a score of 10. If it is blue, I need to give it a score of 20, right? And 90% of people were able to explain this when they were talking about it, right? And I'm telling you about, these are folks who are in this batch right now. So it's not about how to, that, oh, okay, somebody was not able to answer it. But what I'm trying to explain is that when you think about a logic in your head, how does that translate to code, right? How do you actually take that logic that you can say verbally, but translate into logical programming constructs? The first one that we are looking at is decision making, which is through if and else conditions, right? So what we'll do is that imagine I have a local variable where I can say, character box is equal to, say, I denote it by R if it's red, right? Or I can simply say B if it's something else, right? So all I'm going to do is, now I have to think about, hey, can this box be red or blue? And I need to check whether it's red or blue, right? So if it is, so if I'm just verbally saying it in English, normally I would say, okay, my box can be red or it can be blue, right? Now, the moment I use the word or, that's an indication for you that this is an else condition, right? So here it will follow in this section that it can be red or it can be blue, right? If it is, it can be red, maybe it can be blue at the same time, right? It has two colors, I don't know. If that was the case, if I didn't say explicitly or, then I would have used this kind of a condition, right? Where it is one if and then another if, right? So the ball can be both red and blue. Maybe half of it is red, half of it is blue, something like that, right? But the point is that here I said explicitly that the ball is either red or blue, right? So it can be red or, that's a clear indication that I need to use this format. All right. So now that we have first nailed down that it's that kind of a format, now we need to figure out how we actually put this condition into place. So for that, we first defined a variable box, and we don't need anything more complex. We just use a character to indicate that it's an R, which indicates that it's a red box, or indicate B if it's a blue box, right? Because we know we are just dealing with these two colors. All right. So now what do I need to do? Now, if this box is given to me, I need to write some logic to figure out what is the value inside it, right? If my interviewer is asking me that you're given a box based on its color, tell me what score value it will be, right? So all I need to do is inside my box, when I set the condition was box is red or it is blue, right? So box is red. I'm just writing it right now in plain English just so that we can understand how this translates into code, right? Box is blue, right? So instead, now we got to actually convert this into code. Of course, this is not code. This is just pseudocode, right? Where we are expressing programming things, but in normal English language. So that's anytime an interviewer tells you that you can write pseudocode, that means you can write something like this, right? And this is perfectly fine. Box is red, then the programming language you're coding in or writing in doesn't matter. They are looking to understand how you think about solving this problem, okay? So, but now since we are implementing it as well, right? So the next step would be to translate this into code. So in this case, all we need to do is box is equal to R. Now we know that it can be either R or it can be B. So for me, translating this into a simple programming construct is much simpler, right? Box double equal to B. Now, okay, sorry, I missed this bracket. All right, so yeah, okay, I'm missing another bracket here. Okay, so now we have translated our basic requirement of detecting first figuring out that whether the box is red or whether the box is blue, right? We have written a pseudocode version of it and we have written the actual coding version of it, right? Now what we need to do is we need to, well, in this case, we need to just figure out what the score is, right? We don't want to figure out what the total score is because we just have one box. Total score will always be the same as the score for the current box, right? Now, in this case, we know that the score is that the box is R. We'll simply just do a simple cout. We'll just display it onto the screen and put the score out. So box is red, score is for red we have 10. Okay, just make a copy of this, and because we know that if it's red or if it's blue, and I just change the parameter value here, right? Okay, it's blue. All right, so now we have figured out how to write a simple if else condition when I can think about how to formulate a logical expression in my head, right? I was given this problem and I was able to think about, to calculate the score, I need to check what is the color of the box, and based on that color I'm gonna give it its score, right? Score value, point value, whatever it is. So let's just quickly run this and make sure that everything looks good. Oh, we have this unnecessary hello world. I'm just gonna remove that. Red, so box is red and the score is 10, right? If I change this to B and run it again, now it should display me that the box is blue and the score is 20. Okay, so hopefully that clarifies some basic constructs around how you want to think about a problem and then translate it first into pseudocode and then convert it into actual code. Because once you have done the pseudocode of it, trust me, 80% of the job is already done. Rest remaining 20%, even if you, during an interview, even if you get certain things incorrect, right now I have the luxury of hitting run and seeing errors, right? But most of the time they might ask you to do it on the whiteboard or on a piece of paper, right? You might miss out the semicolon here, right? You might miss out this here, right? Don't worry about it. Most engineering managers are not looking for these kind of things, right? Because editors tell you about these basic things. They want to see that your logic is correct, So focus on the logic part of it first, and that's why we've written the pseudocode first before we moved on to writing actual code. All right. Hopefully it's making sense. Just feel free to put down any questions in the comments in case you guys have any. All right. Okay. Cool. So now that we have understood this basic thing, you'll notice that, okay, let me just fix these errors that I created right now. So you would notice that there is a lot of repetition that's happening, right? This statement and this statement looks exactly the same, except there is this red and there is this blue, and then there is this 10 and there is this 20, right? But this look exactly the same. So in programming, we have this very famous concept called DRY, right? What DRY stands for is do not repeat yourself. Okay, so do not repeat yourself. This is called DRY. You can Google it. It's a very famous programming concept, right? So DRY programming, do not repeat yourself. So what this means essentially now if I look at it, that I'm almost, apart from these two values, I'm pretty much just copy pasting. I actually, if you saw it, right, like I actually copy pasted the entire thing and just changed those two values. So this is a good example that I'm actually doing repetition. And these, wherever you see this kind of repetition, those are the prime examples of where you want to introduce something called as functions. Okay, so now what are these functions? These functions are basically repeatable piece of code. Okay, so something that you put together inside a body of a group of statements that you will just repeat on demand. Okay, so I'll show you guys a quick example here. So don't worry about the syntax, I'll cover these things in detail. But print score red. Okay, so I'm going to cut this out from here, I'm going to paste it here and do print score red. So what I did here was that I removed I removed that line of code and pasted into something else, which is again encapsulated with these curly braces, right? That indicate a logical body, right? A logical body of code. So sorry, 1 second. Okay, I don't have anybody else. All right, cool. So what essentially I want to do is I want to make sure that anytime we want to do repetition, we want to put things into a function, because we do not want to repeat ourselves. We do not want our code to be repeated over and over again. Okay, but if I did this and I cut this thing out as well, I would end up creating unnecessary two separate functions. So first, let's look at what this function does, right? So all we're doing is that if the box is red, we want to call a special function, and when the compiler is running this code, again, main is also a function, right? As you all know that this is the main function that gets called by the compiler when the program first starts, right? So inside it, first it executes this line of code. It creates a local variable box and puts a value of b in it or r in it, whatever it is. And after that, we're checking for this if condition that we just created. And if it's true, then we go inside it. And now we're calling this function. So what that means, actually calling that function, what does it mean? The compiler goes from here, jumps to where this function is, and now starts executing whatever is inside this function, right? So how do we define a basic function? So first of all, we need to define a return type, right? So this return type specifies that will this function return a value to the function that was calling it. Okay, in this case, we're calling this print score red function from our main function. Main is also a function, and as you can see, main returns a value. So main, we have defined that it returns an integer value, right? So by default, internally, main will always have like a return 0 at the end. You would have noticed this in a lot of the dummy programs that you might have seen. It's always comes in with a inbuilt return 0 kind of a thing. And the reason for that is because it has a predefined value integer. Now void, when we say void, we are saying that this function does not need to return a value, because all inside this function that we are doing is we're just displaying a value, or rather displaying a string in this case, right? So in this case, we don't need to return a value. Can anybody tell me why do we do an int on a main? Anybody? Does anybody have an idea of why is it that main is not a void but an integer? If someone knows, you can unmute yourself during this time and then just, share whatever you think with the class as well. Okay, we'll come back to it. So I'll let you guys think about it a little bit till we cover a lot of things. But we'll come back to why do we have main as an always has an integer as well in its return type. Why is that the case? Okay, so now we have this print function. If we want to really follow this dry principle, then we should create a function out of this as well, right? But if I created a function like this again, then we would end up creating two functions saying, void print score blue, right? And then this std out statement would come here, which seems kind of wasteful, right? That we said we don't want to repeat ourselves, but all we did was we ended up calling two different functions and in two different places, and we still have that repetition of code, just that it's now inside a function instead of the main function, right? So how can we solve this scenario? So in this case, we're gonna create a common function called print score, and instead of directly putting in blue and red as hard-coded values, we're going to pass these as input into the function itself. Okay, and the way we do it is through arguments, function arguments, right? So we're going to do a string argument. You can do a character argument. Okay, I think I might need a class for this, right? For a string, or is it like capital S? Sorry, I'm more of a C# guy. C++ is as new to me as it is to you guys probably. So pardon in case I F up in between as well. So all right. So generally what we want to do is that we want to do a common function called print score, and say we're going to pass in the score value right now. Okay. So we're going to pass in an integer, which is the actual score value, whether it's 10 or 20, and then we want to print that. Okay, so I'm just going to copy this particular statement and say that, hey, the box score is, then we know that whoever is calling this function is supposed to pass me a function, an integer argument that represents the current score value. So instead of hard coding this value, so this is what hard coding is, right? So we have, irrespective of whenever you call this function, from wherever you call this function, it will always say that the score is 20, right? So instead we want to do a generic behavior which says that the box score is this. So now I can do, instead of calling the other function, let me keep it there but comment it out so that you guys can see the difference. Print score, and now I'm going to pass it the value 10. In this case, I know that I am executing the red block, that my function, that my current box color is R. So I'm going to pass in the corresponding value of 10. And the same for here is print score and then 20. Okay. So now based on whichever, okay, sorry, two brackets. So whichever condition it is, I always am able to pass a score value into this, and I don't need these functions anymore. Okay. So now with a help of these function arguments, which are nothing but local variables that get passed into a function by whoever is calling it, I have successfully implemented dry, right? So now I'm not repeating myself. This entire statement is not repeated. Okay, I've created a function. It takes in that argument It doesn't return a value, but for now, it just prints that score to the screen. So let's just run it and make sure that everything is looking good. Okay, so the box score is 20. If we change the value to R, run it again, box score is 10. But what happens if I change this value to something G, right? Green. We don't have a condition for G. We specified that our requirement was that the game has only red and blue. Suddenly somebody introduced a blue or a green box as well. But now, right now, our code doesn't handle that anywhere. So let's see what happens when we run it. Nothing. We don't get any output. Why? Because it doesn't specify this. It doesn't satisfy this condition. So box is equal to R is also not true. It doesn't satisfy this condition, and essentially this function never gets called. So we don't see anything on the output. Okay. So here this final else condition will come into play, right? So in this case, what we want to do is that if the value hasn't matched anything that we were expecting, right, we're just gonna put in some standard which says, hey, let's just print the score 0 to the screen so that the user know that for this particular box they didn't get any score. Box score is 0. Okay, so now if this value changes tomorrow to something X and we run it, we know that it will again show box score of 0. That means we need to now go in and explicitly give it a score value, or we know that this value is something that we do not want to worry about, right? Maybe these boxes don't have a score value. They're just there for the heck of it, right? So somebody tells you that, okay, now we're adding a new box of say green, then you go in and implement another if else condition, else if condition that handles it and passes in the correct score value. For now, we're just assuming that it's not there. These are the two ones that we want to currently handle. All right, cool. Oh, sorry, not return, R. Now, right now we looked at only functions that return a void. So going back to, if we wanted this function to kind of return something as well, right? So simply that void gets replaced by an integer or say a float. Whatever is the data type that you want this function to return, then that is the value that you want. That is the value or that's the data type that you'll put here, right? So whether it's integer, float, double, long, you can have custom data types as well. We'll cover those later. But the idea is that you have to have, whenever you're specifying something apart from void, then you need to have a return statement, right? Return statement indicating the respective value of it as well. Okay, so you need to have that particular thing. So in this case, let's imagine that we want to return an integer, and what we'll do is we'll multiply the score by 10 and return that value. Okay, maybe we needed to do some calculation on top of it, but my logic says that whatever is the score value, I need to return it into a multiple, right? Like I need to multiply it by 10 and then return it back. So now how will I capture this return value? So whenever I call this function, wherever I call it from, right? Since so far our function was basically handling void as a return type, which means that it didn't return anything. We just simply wrote print score. But in case now we want to print its value to the output as well, or rather store its value, right? In this case, I can actually create say a local variable. I'm going to call it multiplied score is equal to print score and pass in 10. Now when I call this print score this time, I am storing that return value in a local variable called multiplied score. And let's put this also to the output and see what the value is. So multiplied score is okay. So all we are doing is that because now we have defined this as an integer, we know that this will have a return statement that returns an integer value. and accordingly we'll just do a print on it. And sorry, we call the function, pass in the right argument. Whatever this argument is, it will get multiplied by 10, and then the result will get returned as an integer, right? Because it's returning this. Okay, so integer into integer is always going to result into an integer, so your output is going to be an integer. Right, so hopefully this is making sense. So we're just gonna, so okay, we are specifying the boxes are, which is red. It will come inside here, it will call this function, get a multiplied score back, and we'll see that the value increases. Right, so we should see first that the score is 100, so the box score is 10, and then the multiplied score is 100. Right, and we didn't have a delimiter here, so you saw this yesterday briefly, that we had this something called as an endl, right, which basically gives like a next line feed, or you can even do something like /n, where it'll break this line after this. So here you can see that the output is, you know, sticking to each other, right? It's all in one line, right? But if you want to break it down and to bring it to into the next line, so we use something called a /n, which is the next line feed basically. So it's just inserting a /n means it's terminating that line and bringing it into the next line. Okay, so if you run this, you'll see the box score will be on one line and the multiplied score will be on the next line. So we have the box score here and then the multiplied score on the next line. Okay, similarly, if you wanted to print something after this as well, then you will have to add in that here as well, right? /n kind of a thing. Okay, we could do the same thing here as well, but you get the idea that you can call a function, get a return value, and that way we do not have to repeat ourselves. Okay, now here we are calling print score and passing it 10, and we're capturing the return value inside this multiplied score integer variable, which is defined inside the main function. Right, what about this one, and what about this one? Right, we are calling the same function with a different argument value. In this case we are passing 20, in this case we are passing 10, but there is nothing on the left side of it. Right, we're not storing the value that this print score function is returning to us. Right, but still our program ran fine. Yeah, so why is that? So let's change it to blue so that our else if condition can become true this time. Right, this time it will not go inside the if statement, because we're saying that box is B, right? So this line will never get executed, this line will never get executed, instead this line will get executed. Okay, so we'll call this function, we'll see this line show up, but then what about this return? Right, we aren't doing anything with that return. What happens to it? Right, so let's take a look first what happens. So does it even run? Okay, seems like it's running. So box score is 20. All right, cool. Now what will happen? What happened to that return value that we had? Right, essentially all we are doing is we are saying, hey, we don't care about that value here. In this scenario we cared about it because we wanted to display it onto the screen, but right now in this case we don't care about it, whatever that return value is. So we're good, we can just ignore it. So if your function has a return type, integer, float, double, whatever it is, right, if it has a return type, it needs to mandatorily have a return value or a return statement. Okay, if it does not return, then that's a compilation error. So if I comment this out, basically you see this wiggly line under my closing thingy, right? So you'll see this kind of an error, control reaches the end of a non-void function. What this means is that the compiler runs through this function one line at a time. So it executes this line, it executes this line, it's a comment, it ignores it, and it reaches the end of the function. Typically for a function that has a return type defined, the compiler should never reach the end, because the function should have something defined as a return. So from there, the flow of control will go back to the place where the caller was. So if we called it from here and then this return was executed, then the flow of control should come back here. Okay. So what I'm trying to say here is that it is mandatory for you to have a return statement whenever you have defined a type apart from not void, right? So wherever it's a void, you don't need a return statement. Whenever it's not a void, you need to have a return statement. But from wherever you're calling it, you can wish to ignore the value that the function returns. That is up to you. Here we captured that value. This place and this in the else if and the last else condition, we don't capture that value because we don't care about it. Okay. So if you care about what the function is returning, you need to store it. And this variable in which you're storing it needs to match the same type. All right. There are ways where you can avoid matching the type and you can do something called as a typecast, but we'll look at it in one of the later classes. Okay. So for now, just understand that whatever is the return type, that needs to match. Okay. So hopefully this is making sense. Any doubts so far? Okay. In case anyone has a doubt, just feel free to put them in the chat. Once I stop at any logical points, I'll pick them up. Whatever are the pending doubts in chat. Okay. All right. Cool. So hopefully this super important concept of dry is clear to you guys. So I'm just going to move it at the top as well. Most of the senior engineers, trust me, do not know about this stuff. So if you come out to an engineer being a fresher and say, oh, okay, I know what dry is, and I code in a way that I make sure that I'm not repeating myself, that suddenly gives you a thumbs up, right? So in the eyes of an engineering manager or a hiring manager, you certainly get a lot more points because you understand these basic fundamental concepts that companies nowadays expect you to do. Okay. All right, cool. So we covered conditional statements, we covered functions, we covered arguments, we covered different types of data types as well, right? So one more thing that we want to focus on is loops. Okay. Again, so it's super important to understand when to use a loop, how to use it, what exactly it is, and basic constructs around those as well. So in this case, so far, we were always dealing with one particular box, right? So we said that we have one box, whether it's red or blue, and based on that, we decide what needs to happen. Okay. Now, what happens if I tell you that instead of this one box that we did, with this, now at the end of the game, you have a full sequence. Sorry, 1 second. Sorry about that. So imagine that at the end of the game, you have a sequence, something that resembles red, blue, maybe blue, sorry, and then blue, and then red, or blue, whatever, right? All this indicates that during one game, the player went ahead and picked up boxes in this sequence. So now at the end of the game, I want to calculate what the total score is. Okay. So far we looked at how to calculate the score based on one single box, whether that's red or blue. We were able to calculate its value, or in this case, we were able to print its value, right? But now based on a full sequence, we want to figure out how we want to calculate the total score. Okay. So now when you think about this problem, go back to thinking about how we thought about solving it for a single box. Okay. So when we had a single box, we said, okay, if it is this, then give it some score. If it is the second color, then we give it some other score. And that's what we did here, right? So yeah. So that's what we did. So let me just simplify the logic a little bit. But now what we want to do is that we want to repeat this process, right? What we did for a single box, we want to repeat that process for all the boxes, correct? So we want to take one box at a time, make it go through that same if else kind of conditions that we have defined earlier, and now repeat it for the entire thing, correct? So in this case, I need to use whatever I have created so far, right? Now we have solved the problem of one box. Now we're going to solve the problem for all the boxes. So we do not need to resolve the problem for one box because we have already solved it, right? So think of it like a small sort of a solution ball. So we have a solution ball. Now we have solved it for one box. If I put in a box into it, on the other side comes out the score, right? Now I need to do is keep putting in one box at a time or one color of a box at a time, and it'll keep giving me score from the other end, right? So whatever I've written here, the logic that we have defined so far, that is that solution ball, right? The solution ball takes in a box which is defined by this, and it has a color value, and based on it, it gives me a return score. Well, right now we are printing it, but the idea is to return it. First, we'll print all the things, and then we'll figure out how to total it up as well, right? For the total score. So that's how I've broken my problem down into smaller pieces first. Okay. So if I was taking your interview right now and I gave you this problem first, okay. So first, let's understand how we're going to approach solving this. So you have red ball, red ball, blue, red, blue, whatever, right? There is a sequence of balls. Now you need to tell me what the score is. Go, right? If I'm the person that is being interviewed, this is what's going on in my head. Okay, so I've been given a lot of balls or a lot of boxes, and based on the color, I need to figure out what the total score is. Okay, so first let's break it down into the simplest unit of work. The simplest unit of work here is one single box. So let's first figure out how can we translate the color of one single box into score. So if the box is something, this is the score. If it is something else, this is the score. And that's what we have done so far, right? All right, now we have figured out the solution for one box at a time. Now we need to repeat this process, right? We need to repeat this process for the entire sequence. So whenever you're thinking about a solution and you get this repetition in mind, that's the best place where you'll put a loop. Okay, wherever you have to repeat something or scan through something. When I say scan, imagine if an array is or a sequence is nothing but characters written next to each other on a sheet of paper in front of you, right? When you're reading it through your eyes, you're starting from the left, you're reading one character at a time and going left to right, correct? So all you're doing is your eyes are scanning from left to right, or if it's written vertical, then top to bottom, right? Whenever you're doing this sort of a scan operation, you're going over the entire thing in a sequence. That's where you put a loop, all right? So now whatever solution that we have done, we'll implement that in a loop and we'll repeat it for the entire thing, okay? And that will give us pretty much all we need. Okay, so for this particular thing, we need to define that for this sequence, how are we going to first, well, the interviewer asks us total score. We're not going to directly jump to total score. We're going to first figure out, can we even print out the individual score values for each of them, and then figure out how to do the total score. Okay, so one step at a time. Okay, so now we have some logic that says, okay, this is the score, this is the score, this is the score. So I'm gonna revert to the original solution, and for now I'm just gonna comment this out, which just says that if it's red, print score 10. If it's blue, print score 20. If it's neither of those two, I'm just gonna print 0. All right. Now going back to my, going back to my dry approach, I'm going to simplify it. It looks very, um, ugly to me. So what I'm going to do is I'm going to say void print box score. I'm going to create a new function. In this case, I'm going to pass in a character value of box, and I'm just gonna cut this entire logic and paste it here. Okay, so now all I have done is that I've removed my logic from the main function, and instead I've created a small function, much like how we did for this particular thing, right? This just simplifies how I look at code, right? So now this function, okay, so let's look at what this function is. Again, it's of the type void, right? It says print box score. Okay, here I'm explicitly saying that I'm printing the score for a specific box, and as a result, the argument that I'm passing inside it is nothing but a box. Inside it, when I'm passing it, when I'm calling another function inside it, that function is called print score because I'm passing it in a score value, right? That's why I'm naming this function as print score, and I'm naming this function as print box score because I want to be absolutely clear what this function is for. This function is specifically taking a box and printing its score. And this function is directly taking a score and just printing it. Okay, so there's a difference between the two. All right, so now this does is that I can just hide this function away. I've just hidden it, it's there, right? So I've just hidden it away. Now when I'm solving the full flow of all the boxes, I do not need to worry about this function. Because I've solved it for one box, I kept the solution away. I know I have the solution for one box ready. Anytime I want to solve for one box, this is the solution I'm going to use. Let's not worry about that anymore. Now let's worry about how can I scan through my entire list. Okay, just to show you, I'm going to do print box score and pass in this box value. This is exactly the same as the entire code we had before, where I just removed that particular piece of code and put it here. Why? Because I want you to logically think about this is the solution for one single box. Okay, this is the solution for one single score value, right? Whether the score is 10, 15, 20, 30, whatever is the score, it just displays it. But this function takes in a box and calculates the full solution for that particular box. Well, in this case, when I say calculate, it just displays it for now to the string, to the screen, correct? All right. So now I have the solution in mind. Now this is a this is a solution that's ready, and I'm going to reuse it over and over again. Again, going back to that dry principle, I don't want to repeat myself. I've put this thing inside a function. Sorry, 1 second. What happened to this? Okay, not sure what. It just went on connecting. All right. Anyways, so let's continue. So, okay. So now I want to think about that scanning part, and this is where loops come in. So what typically a loop is that we take one element at a time from a list, from an array, from linked list, any of the data structure, it doesn't matter, right? The core fundamental is that you have a bunch of items that you want to go over one at a time. Okay, when you want to do that, that's where you use a list, or that's where you use a loop. So the most common example of a loop is a for loop. Okay, and what for loop says is that starting at certain point, ending at another point, while your conditions between the loop are satisfied, you keep continuing. Okay, so int I is equal to 0, which means that I'm going to start with an initial value of 0. Now what is this I? I'll come back to it, but I'm going to start with a initial value of 0. Okay, and then I'm going to continue up to say 10, which is the maximum value that I want to continue to, and then I'm gonna increment I at each step. Okay, so what the statement is saying, that my value of my loop will run essentially 10 times. Okay, so it will start a local variable called I. It will start at 0, and then it will continue from there till the value reaches 10, and that's where it will stop. All right, so this is how you will typically think about it, and after every step its value gets incremented by 1. All right, cool. So once we have this, all we need to do is, so we'll define a simple character array. So let's do something like boxes. Okay, and you're just gonna put in some values right now. Let's say R, say B, and R. So for now, let's say we're just gonna do 3 values for now, just to keep it simple. Okay, so here we've specified that our boxes have our input array of boxes has 3 values, R, B, and R. And all I'm gonna do is I'm gonna take an integer loop over all the different values of this particular boxes, and I know that it only has 3 elements in it. Okay, so I'm going to start with 0, then I'm going to go to 1, then I'm going to go to 2. When I come to 3, this condition gets checked, says I less than 3, 3 is not less than 3, so this returns false, and that's when I come out of the loop. Okay, so here what I want to do is I want to simply say print box score and pass in boxes I. So what I'm doing is actually comment these 2 out as well, because we don't need them anymore. So what I'm doing is I've defined an array which is nothing but a sequence of boxes much like this, right? And based on that sequence, all I'm doing is I am looping over everything inside. So this is how I'll access a specific element from an array. I'll just say boxes and then the corresponding index, right? And this is how I'll know that I've the first value, the second value, the third value. Okay, so print box score. Box is this. Yeah, print box score box from sorry. Yeah, so once we call this function, we pass in. The first time we iterate, we pass in red. The second time we go over this, we pass in B. The third time we go pass in R. Okay, so let's run this and see if everything looks correct first. Okay, so box score is 10 because we have a value of R first. Then we have box score of 20 because it's B, and then box score of 10. So now because I had created this function and kept it aside, when I was actually implementing this entire thing, I didn't have to worry about what's inside it, right? All my score was now neatly printed out already. So this gives me that flexibility of, solving one sort of logical problem. The first logical problem was, let's figure out a solution for one box. We figured it out, we kept it aside as a ready-made solution. Now we want to solve it for all the boxes. So we create a loop, we go over and scan each individual item inside it, and we call the solution for a single box, passing it in one box at a time. And now we have a full solution ready. Okay, so always try to think about how you can break a problem down into its individual components and then build solutions ground up, right? Build the solution to the smallest problem, then build the solution to the second biggest problem, and then build the solution to the biggest problem using the solutions that you have already built. Okay, so if you were trying to think about the whole thing, you would have started with like a for loop directly, put something inside it, then gotten confused, etc., right? But with now just 2-3 lines of code, essentially we have at least printed out all the numbers. We still need to do the total score part, right? Cool. So anyone knows now, based on what we have done so far, how should we go about, instead of just printing the score, we want to actually, as our problem statement mentioned, we want to calculate the total score, right? So does anyone know, or rather have a solution to how we can do that? Any suggestions? No? So we have score values that we are printing out to the screen, correct? So now we need to calculate what the total score is. So all right, cool. Let's take a look how we'll do that. Okay, so here, so Arushi says that every time we loop over, we save it in a variable. Okay, yeah, that's correct. Well, that's partially correct, but yes, you are on the right track, Arushi. So every time we loop over, we need to do essentially something and figure out, what the value is. Okay. In this case, now what we'll do is we'll go back to this return value, right? Remember when we defined this return value, we weren't really reusing it. We just used it to kind of show, right? Okay, this is the return value. So now instead what we'll do is this print score just prints it. So first we'll make the change that will turn it into a void. And the moment you turn it into void, you'll see this error, right? Because a void function should not return anything. So the compiler will tell you that, hey, there's a mistake, we shouldn't be returning. So let's remove some of this pieces that we don't need. Okay, so what we're going to do is we're going to turn this print box score function into something else. We're going to call it get box score instead of print box score. Okay, because we're saying get, here also we'll have to make that change. We'll say get box score. Now just looking at this function, I can say, oh, okay, I'm trying to get the value of a score for this particular box. Okay, when I'm saying get the value, logically seems like that the function should return something, right? Because I'm saying, hey, function, this is the box, right? Get me its value. So naturally, we should return. So anytime you're seeing something like a get kind of a function, that will more likely return a value. Okay, that's just a standard convention. The other, it's like two sides of the same coin, right? You'll have functions such as get, and then you'll have functions such as set. So if it was like set box score, it might be taking in a box character as well as a score and setting its value and saving it for future reuse, right? But in this case, what we want to do is if there is a score or if there is for a particular box, we want to get its score value. Okay, so what we'll do is we'll directly do a return 10, and here we'll do return 20, and here we'll do return 0. So all we are doing is inside the same if conditions that we verified, that we built the solution using, we're just saying, okay, we know that this box is red, so we can just return a 10 directly from there. And here we know that the particular box that is right now we are talking about is this box, and this box has matched to B, that means it's blue, so we're going to return the value for blue. And else it didn't match anything, so naturally we need to return 0. Okay, cool. So in this case, you might notice that there is not every return statement is inside the if else condition, correct? But still the compiler is not complaining that return has reached the end of a non-void function. Why? Because this else condition will get executed no matter what. If one of these if gets true, the corresponding return statement will get executed. If neither of this is true, if you have a box with like some random color, then this else will always get executed. So irrespective of which if else it falls into, this will always get executed. One of these if else will one of these returns will always get executed. That's why you don't see this complaint. If this if last if also had a, or rather if this didn't exist, then you'll see this complaint error show up, say control reaches the end of a non-void function. And if I now call this function where we have a box of a random color X, right? Now this will throw a error. Let's run it and see. You see an error, warning generated. Control reaches the end. Okay. So in that case, if this was the case, you can just simply say return 0 as well. But we've defined it, we've printed it. So both of them logically seems correct. Okay. All right, cool. So here now we have defined this function, which basically returns us the score value. We actually use this because it prints out the 0 for us as well. So we're just going to use that. All right. Okay. Now the solution is this particular function is ready to use for an individual box. I do not need to worry about it ever again. I just minimize it and go on with my happy life. Now we're saying that get box score. Okay, so this will return us the box score. Okay, so what I want to do is I want to first create a new integer that says total score, and this is where we'll keep total score. Size says int x is equal to get box score boxes I. Yeah, okay, yeah, that's correct. The only thing there is that try not to name variable x, y. They just aren't readable, right? So if you know what they're for, just create the name appropriately. Okay, int score is equal to x. Okay, it didn't take me more than 2 seconds extra to type score instead of x, but when somebody is reading this code, even when you are reading this code, you know what the score is, but you probably will forget what this x is, right? And you can see that we've already started adding so many functions, so many code just in like this last half an hour. If you were building this program for just one day, you'll forget what that x was. So always name your variables, and it makes you a better programmer because other programmers can read your code as well. Okay, cool. So here we will say int score is equal to get box score, and get box score will return us the value for the current score. We're going to keep it inside the score, and here hopefully you guys would have guessed by now that all we're going to do is total score is equal to total score plus. So at each step we are adding the value of the current score for the box into the total score, and at the end of it we know what the total score is, right? So std cout total score, total score. Okay, now because we have put this function away nicely and calculated the score inside the function, when we were writing the bigger logic we didn't have to worry about it, right? Now imagine if I was building a game on top of this. I just built a thing that takes a sequence and calculates the total score. First, let's run this and just make sure everything looks good. All right, let's run. Okay, so box score is 10, 20, 10, and total score is 40. That looks correct. As you might have noticed that we had this X as well. So are we not printing the box score 0? So print score, we are putting this value 0. And so we should have seen, oh, that's because our loop goes only till 3. So now we should see another statement saying, yeah, box score is 0 and the total score is still correct, which is 40. Okay, cool. So now imagine that I was building something even more complex, right? I just didn't want to worry about one score. I didn't want to worry about, a sequence of score for one player, but I now have a multiplayer game. Imagine this was PUBG, right? You have 100 players in one server in one game session, and now you want to build a system where at the end of the game, you need to give out who scored how many points or something, right? And you have a sequence for each person, right? So how will you kind of, do that? Can anybody guess? So now we're building something where for 10, 20, 30, 100 people, we want to calculate the score for that particular person, right? And we want to do it for everybody on a PUBG server, right? So hopefully the question is clear. So can you guys think of a way how will we be able to implement using the solution that we have written so far? Any suggestions? So it's exactly on a similar lines as to how we created our logic so far, right? First we solved it for one box, then we solved it for a sequence of boxes, right? Now we're going to solve it for a sequence of players or a lot of players where each player uses this solution, right? So we solved it for one box, we solved it for a list of boxes or an array of boxes, whatever you want to call it. But this array of boxes represents, say, one player. And now we're just going to create another loop. We'll solve it for all the players where for a single player, this is the solution that I've already created. And I don't need to worry about it again, right? So think of it again. And all we're going to do is in a very similar fashion, we're going to create a new function called void calculate, say, player score. Okay. Now I just created this function. I don't know what I'm going to put in it. Let's figure out how we're going to do this. So calculate player score. I want to take this entire logic of total score and I want to move this inside this function. Okay, so this is going to calculate the total score for this particular player. So now what do I need? I need these boxes, right? So I need these boxes. So how am I going to do that? So I can pass this boxes as an array here, right? So I'm just going to say character boxes array. So I'm going to take a character array as input into my function, okay, and calculate the score the way I was calculating before, and that's pretty much it. That's going to print me the full score. Okay, so now I had this function for boxes. I'm just going to call the calculate player score with like different boxes, right? So in this case, I'm going to pass it boxes, which is the first. So this is for like the first player, and say I change the value to something else, right? So this is like for player 2. No, I can't do that. So let me just change the name to be boxes 1, boxes 1, boxes 2. And in this case, say I want to do B and R and say another B or something, right? And then this is an array, that's why it's complaining. And this is boxes 2. And this is also another B. Okay, so now here you can see that I've created another function out of it, right? And now I can call it as many times as I want, right? I'm calling it for player 1, right? I'm calling it for player 2, and I'm going to get the full score out of it as well. Right, so let's run this and make sure. Okay, so so we missed a slash n somewhere. I think, yeah, okay, at the end of the total score we missed a slash n or an endl, either one. So let's run this again. All right, so for the first player we have box score 10, 20, 10, 0, and total score is 40. For the second player, 20, 10, 20, 20, total score is 70. Looks correct. Yeah, cool. So hopefully this gives you an idea how we've used loops and functions, which are the most simplest thing in pretty much any programming language, to solve a complex series of problems that will always are increasing in difficulty, right? Now imagine yourself in an interview where I ask you a question that for 100 players, I need to solve or I need to calculate total score where each player picks up a sequence of boxes, and for each color of the box, there is a specific uh, score value. So at the end of the game, for every player, I want to know what the total score is. Okay. Now, if I throw this out in front of you, you'll be like, okay, it seems super complex, right? So absorb the question in, think about it, and break it down into its smallest piece first. Okay, what are we doing here? We have to calculate the score for every player, right? How are we calculating the score? We have to calculate the score by totaling up the score of all the boxes, right? How do we know the score of a single box? Based on its color, right? So that's how we've broken the problem and then solve it in reverse. So score for all the players, score for a single player, score for a single box comes down to an if condition, right? So implement the if condition, implement a loop over it for a single player, and then implement another loop over it for all the players, right? Here I just put it inside like just to show you guys this, but essentially if we were getting this input from somewhere else, we could have implemented it as a loop, right? And just call this function inside the loop and pass in different arguments. Okay, so now this way we have broken this seemingly complex problem into its smaller and smaller, and the smallest piece, solve the smallest piece, then the bigger piece, and then the biggest piece. Okay, hopefully things are making sense. Yeah, you guys following along? Yes, no? Can you guys just respond yes, no in the chat, something, so that I know that you guys are able to follow along how to think about breaking a problem down into these basic fundamental uh, you know building blocks. We haven't talked literally about anything else except for if condition, creating a simple function, passing in arguments, and a simple loop, right? We haven't really talked about anything more complex than that, right? So just by that, you can solve so many problems. And so I think, let me think. Yeah, I think that's pretty much the kind of a core example that I wanted to cover today. So this gives you guys a basic idea about how to think about problem solving in general using absolutely nothing fancy. And trust me, this is nothing that you need even C++ for. We didn't create anything C++ specific, right? You could have written this in C as well if you're comfortable with C. If you're comfortable with Python, you could have written it there as well. So you don't need any fancy programming language to write solutions to any of these basic kind of problems. All right, cool. So this is typically how interviewers will evaluate you when you are approaching any kind of problem solving. Okay, so how you saw me today, go back and go and look back on this session in the YouTube video once it's up, and practice this often. When you're taking a problem, speak it out aloud, so that when you're doing an interview, you are naturally doing it. You're not forcing yourself, because half of the time, even if you fuck up badly on the solution, your end result is bad, not correct, but your thought process was correct. You were thinking in the right direction. The interviewer will help you and be like, oh, okay, yeah, because people want you to see, people want to see other people succeed that are making a genuine effort. So you want to be seeming genuine, right? I could have come in, written these functions, and just told you that, okay, so we're going to calculate this, then we're going to calculate that, then we're going to calculate that, and that's it, right? But you would have not learned anything about how to think about how to solving it. So most of the time, what interviewers want to see is how you solve a problem, how you approach a solution to a problem. That is way more important than the end result. 99% of the time. That is way more important than the end result, right? So even if you made a silly mistake somewhere in this particular solution, it would have been totally fine. Okay, so maybe you didn't handle this case where X was not the case, right? And then the interviewer will ask you, okay, so what will happen if you put in an input where it's neither red or blue, maybe due to some error condition, or we added a new color box? What do you think will happen, right? Then you're like, okay, I did not handle that scenario. Let me see where. Okay, let's look at the first question, first function, highest level one, right? Okay, we're not doing anything with the boxes here. Okay, let's dig inside this function and see what this is doing. Okay, yeah, so here we are handling the actual color. So we're saying R, B. All right, let me add in this else condition because we missed it, right? Then they want to see that given given a direction that, hey, you missed possibly this scenario, can you figure out where it is, right? And now by you telling yourself, oh, okay, I think we didn't tackle this, let's start with the highest level function. Let's go inside it and see where. Okay, so we're not handling colors anywhere. Okay, sure, so we can ignore this function. Let's see, go into this lower level function again. Okay, so inside this lower level function, yeah, that's where we're handling. So using this process, you're able to drill down, starting from the highest level solution to the minimum, to the intermediate, to the lower level solution. You're able to follow a process of figuring out where you want to fix this thing that you forgot, and be like, okay, I'll implement it here, and bingo, hired, right? Because they want to see that when pointed in the right direction, can you figure out the solution? Nobody expects you to know all the solution, but are you smart enough to think about the solution and then figure it out once you're given a hint? Okay, cool. So typically that's how, a lot of the hiring process work, a lot of the basic sort of things work. And trust me, I did not ask anybody in the interviews that I've conducted as well anything more complex than this. uh, Definitely not for somebody who's just starting the career. Of course, the interview process is very different when you're senior, 3 years, 4 years, 10 years senior in the industry. Then obviously the interview process is different. But for now, all good companies and good engineering managers are focusing on your thought process, how you're thinking about a problem, how you're coming to a solution, and not just like, oh, okay, yaar, ye if nahi chala, let me put a for loop. Oh, for didn't work, let me put a while loop. Oh, while loop didn't work, let me put a hash table here. Just don't keep throwing darts blank in the air. Step back, think, calm yourself down. All right, this is the problem. How do I break it down? Broken it down. All right, what is the most simplest level solution? And then build it from there. Okay, cool. So now you're given this particular problem. So you're gonna implement an extension of it. The extension is that you have calculated the total score so far, right? So what we're going to do now is that we're going to implement a thing called bonus. Okay, so essentially what this bonus is that if you've played any kind of fighting games, you can get like these combos, right? So essentially what this means is that anytime you pick up a ball of a consecutive color, so red and then red, right? Blue and then blue, right? So whenever you're picking a ball of a consecutive color, then my score will increase multiple times. And what I mean by that is that if this is my input sequence, so the first red gives me a score of 10. Now in my original scenario, the second red would have given me a score of 10, right? But right now I am in this game where it gives me bonuses as well for picking up matching colors consecutively, right? So in this case, I'm going to get a score of 20 instead of 10. Okay, and if there was another R here, right, then the next score that I'll get is 30 instead of 10. And then I go back to B, I get 20, because remember, B gives us 20. And then the second B gives me 40. And if there was another B after this B would give me 60. Okay, so hopefully the sequence is starting to make sense. And then if I have another R, right, and say another B, then this will give me back again 10. And this will give me back again 20. So till the time I keep picking consecutive balls of matching color, then my score keeps getting higher and higher, right? So I don't get 10, 10, 10 for the first three red. For the first one I get 10, then I get a 20. So my total score after picking two boxes is 30 instead of 20. After picking three boxes, which are these first three boxes, my total score is 60. In a normal game, that would have been 10, 10, 10. So total 30. Instead, in this one, I got total 60, right? And then I switch to B. So I get whatever is the basic value of B, because now this has changed, correct? And then because I'm picking now blues, so till the time I keep picking blues, my individual score value keeps getting increased. And then I reset back again. Okay, so this is the bonus problem that you guys are going to try and solve. I'll share the link on Discord for the current REPL, so you can refer to the problem that we have coded today, and then you can copy this REPL into your own and try to implement your own solution on top. Okay, and we can discuss that tomorrow. Cool. So if you've already gone through the interview with me, this is the problem that I would have asked you, but now I want you to implement it, using the constructs that we have learned today. Okay, so cool. Hopefully the question is clear. Any doubts on the question so far? Okay, all right, cool. Looks like the question is clear to everyone. All right, perfect. So let's try and do this, that you guys can implement this particular solution. If you can figure it out, great. It's super simple. Like you can just simply change this to all B's and then one R, and that should give you the sort of the correct score values, right? So this alone is enough for you to test out that your solution is correctly working or not, right? Cool. So let's try this as a bonus problem. I'll put this link in Discord, and yeah, I think that pretty much covers for today. So we are also building a dedicated community of passionate game developers, web developers on Discord. During this course, if you face any issues while building your projects, please feel free to ask relevant questions on our Discord community, and other students who have already done this course will be there to help you out. The link to join our Discord community will be in the description below. We usually publish a lot of information such as interview questions, hiring patterns, what's the latest and the greatest happening in tech industry, both in gaming and web technologies. In order to stay up to date on relevant information, please follow us on our social media channels, linked below.